Welcome students. In this class I will be introducing to you the basics of the ellipse. Now we will be talking about the standard form of the ellipse, which is x squared divided by a squared positive y squared divided by b squared is equal to 1, with a being greater than b. Now the value of a greater than b will determine how exactly the shape is. Now in this case the shape of the ellipse will be in this fashion. Okay, so this is x-axis, this is y-axis, this is the center 0, 0. This is the foci. The ellipse has got two focuses, so why we call it as foci. This is the axis A, and its coordinates are a, 0, and this is a dash, its coordinates are negative a, 0. This is B, it's also part of the axis, this is B dash. Now A and A dash, the axis, they have the vertex as A and A dash, and similarly there is a vertex B and B dash. Now this has got a coordinate 0, B and 0, negative B. Okay, so having got this, now there is something called as the lattice rectum. Now that is a line that passes through the foci. So this is going to be L dash, and the coordinate of the foci is A, 0. Similarly over here there is another lattice rectum which is represented as M dash, and it also passes through the coordinate of the foci, which in this case is negative A, 0. Now the coordinate of the lattice rectum L is going to be AE because it flows through the foci AE. Of course we don't know the y coordinate, so we will just represent it as y1. So that would be the similar case for this M. So it's going to be negative AE, y1. So we don't know where exactly is this point, so it's better to safely place it as M1. Now there is also a directrix for the ellipse. I'm drawing the directrix here. Okay, and the equation of the directrix will be x is equal to a over e on this side. Similarly there is a directrix on the left, and that's going to be x is equal to negative a over e. So the center of the ellipse is located at 0, 0. Now the distance between C and S will be same as distance between C and S dash, and that would be equal to A. Okay, and SS dash will be equal to 2C. Remember that. And the connectivity between C and the major and the minor axis is going to be C squared is going to be A squared negative B squared. So this is the relationship of C, A and B. Now so let me write that down here. So the distance between the center and S, if it is C, the distance between C and S dash will also be C. Okay. Now since we see that the value of A is greater than B, and we have x squared over a squared positive y squared over b squared is equal to 1. The axis of the ellipse is along the x-axis. In fact, AA dash represents the major axis of the ellipse, represents the major axis of the ellipse. Now this is called the standard form of the ellipse. Okay, now B dash represents the minor axis of the ellipse. Okay, now having said all that, the length, let me write down here the following. The length of the major axis is equal to 2a units. Okay. Number 2, the length of the minor axis is equal to 2b units. So number 3, length of the semi-major axis is equal to a units, and length of the semi-minor axis is equal to b units. Okay, so a units and b units. So these are all important. Number 5, the coordinate of the foci. Coordinate of foci are AE, 0 and negative AE, 0. Okay, so for the ellipse, whose major axis is along the x-axis, okay, so that would be the coordinate. And the latest rectum, okay, the latest rectum, that is the line that passes through the focus, that coordinate is going to be L of A, y1 and L dash of AE, y1 for negative y1. Okay, this is going to be AE, negative y1. Okay, is a lower thing. Now next, finally, the directrix is x is equal to a over e and x is equal to negative a over e. So we are basically looking at the standard form of the ellipse. So that is of this form: x squared over a squared positive y squared over b squared is equal to 1 with the major axis along the x-axis. Students, there are a few things you got to know about the ellipse. If I were to draw the ellipse in the standard form, so this is the focus, coordinate a, 0 and s dash negative a, 0. The center is 0, 0, and let us also draw the directrix. So this is the directrix, x is equal to a over e, and we will also draw the directrix on the other side. Just to keep up with symmetricity. So this is going to be x is equal to negative a over e. Now you got to know how an ellipse is created. Now if I take a point P of x, y, and this coordinate or this point is M and this point is S. Now the distance between S and P and the distance between P and M has a constant ratio. So that means when the point P is moving, this line is going to be coming down, right, like this. You follow me? So always this line will be parallel to the x-axis. Okay, and we have, from the definition of ellipse, SP divided by PM will be equal to E. Now what is this E? E is called the eccentricity. Okay, eccentricity of In fact, it's just better to say eccentricity. Okay, I just want to complete the eccentricity of the ellipse, but you don't need to mention it like this. Just mention E is equal to eccentricity, and that is fine. The value of E for the ellipse is less than 1. Have that in mind. And there is also a connecting relationship between A, B, and E, and that relationship is given as follows, which is B squared is equal to A squared of 1 negative E squared. So this is a very important relationship that you have to know. Okay, this is critical. And also, if you take AE to be equal to C, there is a relationship that connects A, B, and C. And that relationship, as I mentioned earlier, is going to be C squared is equal to A squared negative B squared. So this is the relationship. Okay, relationship number 1, relationship number 2. These are all very critical informations that you will have to know. Of course, I have mentioned to you the length of the major axis, length of the minor axis. And this ellipse which we are talking about, x squared over A squared positive y squared over B squared is equal to 1, is the ellipse in standard form. Have that in mind. So when I say standard form, the center is at 0, 0. So that is the meaning for this. So this completes the lesson on ellipse. We will do some questions and